All right, we're finishing it off. 5.4. We're finishing off with conditional probability, talking about what that looks like, and then the general multiplication rule. You'll find it's pretty similar to the regular multiplication rule, but it's good to have all facets of it. So let's start with conditional probability, and that is P F given E. So this is a line that goes in between those two, all right? And it is read, the probability of event F given event E. So the word given is for that line. That's the word given. All right, so but it's read, the probability of event F given event E. All right. So the moral of the story is it's F given E. So anytime you have this line, it's the given that is going to happen. All right. Okay. So suppose a single die is rolled. What is the probability that the die comes up 3? So first of all, we need to figure out what a sample space is, right? And then we can come up with what's going on there. Okay. Now suppose the die is rolled a second time, but we're told the outcome will be an odd number. What's the probability the die will come up 3 at that scenario? So what we're actually looking at here are two separate scenarios. There's scenario 1, just straight up given a 3. Then there's scenario 2. And then what's the probability that one comes up, right? So there's two separate scenarios here. So scenario 1, I know I have to figure out a sample space because it's probability. And we learn probability is always what we're looking for out of the total. So we need to figure out the total. What's the total we've got going for us here? 1, 2, 3, 4, 5, 6. Exactly. 1, 2, 3, 4, 5, 6. Because that's what's on a die, right? That's our options available. So what's the probability of getting a 3 out of this sample space? 1 out of 6. And that's the probability of a 3. Now, on our second scenario that I'm looking at here, suppose the die is rolled a second time, but we're only told the outcome will be an odd number. So what is my new sample space with only odd numbers? 1, 3, and 5, right? Okay, so it has to be an odd number. Then based on this sample space, what's the probability that I would get a 3? 1 out of 3 this time. Do you see how that plays? Okay. So that's what it's looking for. So we're saying, what's the probability if we narrow it down? So that's how we're playing that first one. Okay. Now, when we're looking at these different rules, all right, we can have a conditional probability that something's going to happen there. And so we have, let me scoot this up, the conditional probability rule. And that is if E and F are two events, right? Any two events, then the probability that F given E will happen. Remember, we've got this bar right here. Then we have the probability of E and F over the probability of E. Ah, cool, right? Now, the key to this one up here is this is the multiplication rule. Because it has and. So if that's set up for us, that and that, so then we do the multiplication rule if we need to for the numerator. But this bar right here is going to be that division bar. The key is them together is the numerator. And then just the second event here that is set up after that, given that bar, that goes in the denominator. All right, so let's look at this data table and see how this all plays. I'm going to scoot this up. There it is. The data in Table 8 represent the marital status and gender of the residents in the United States age 15 older in 2017. We've seen this before. This was a data table that we previously worked with. This two-way table, this contingency table. The only thing is our other table knocked off here, And then this one actually sets it up to where it gives us our totals, which is nice. So we don't have to figure that out. Our totals are given to us. Okay, so we want to compute the probability that a randomly selected individual has never married. Ooh, remember, we're doing these special words. There's our special word. Given the individual is male. So we want the probability of never married given we have a male. All right. So if we set this up, when we're setting this up, this is, I'm going to scoot it down over here a little bit. We have the probability that this is never married and male over the probability of just male. Do you see what happened there? Okay. So never married and male, never married and male, those overlap, and that's where that 46 comes in. 0.0, it looks like it's up above in the middle, doesn't it? Over just male by itself is 126.9. Do you see that? And that's how we do it. All right, so then you do this division. Let's go 3 decimal places. So I have 0.362. Plug that into, that's what I get. Is that what you get? Okay, so then this is the probability that this is, the probability that a randomly selected individual is never married, given that they're a male, is 0.362. That's our probability there. All right? Okay, what happens if it's stated this way? Compute the probability that a randomly selected individual is male, given the individual was never married. Ooh, check this out. The probability of male given never married. Do you see what just happened here? Does the order matter? Yeah, it does. Let me squeeze this in, because look at what's happening up here. What is listed second as the given part of it? That's what goes in the bottom. These two together are on top no matter what. But it matters what comes after given, because that's in my denominator. Male on the first one, and what's in the second one? Never married is going to go down there. Yes. Okay, let me make this a little bit bigger so we can see it better. So this is really the probability of male and never married. And it doesn't matter which word you put first or second, because it's where they overlap, right? Never married and male, male and never married, same thing, same thing. But the kicker is the probability of never married in the denominator. So the total of never married is what goes in the denominator. The overlap is still the overlap here. So this is 46.0, which is just 46, right? Over 86.1. The key is the order. What comes after given goes in that denominator, because it's the given that portion. And then what do you get? I got 0.534. Is that what you get? Nice. All right. Okay. Nice. I want to do one more here. So look at this example 3 on the top of the next page. We're going to suppose that 12.7% of all births are preterm. The gestation period of a pregnancy is less than 37 weeks. Also, 0.22 of all births resulted in a preterm baby who weighs 8 pounds, 13 ounces or more. What is the probability that a randomly selected baby that weighs 8 pounds, 13 ounces or more, ooh, there's the words, given that the baby is preterm? So we're looking at the probability of the 8 pounds, 13 ounces, given that we have preterm. So what is it? It's a probability of, and I'm just going to write the weight because that's what we're talking about. The weight and preterm over which one? Preterm. See where this is coming from? The order matters. That's the key to this. So what's a probability that it is the weight and the preterm? Because it says also this is happening. And whenever I'm looking at this, are we writing these as percentages? No. So we have to change that to a decimal. So move it 2 decimal places over, right? 0.0022 divided by the preterm part. That's the preterm part. Again, is a decimal, 0.127. Just pay attention to the order. Look for those keywords that given that scenario. Look for those keywords, and then that's how you pull that off. Okay, plug that into your calculator. What do you get? Let's take this one out to 4 decimal places because it's a long enough way out there that it would be nice. 0.0173. Is that what you get? Okay, so that's the probability that that's going to happen. So let's say this. In all of these, you always want to interpret. So let's interpret this one. We didn't do it on the other one, but that's okay. Let's interpret this one. Let's say, if we say if 100 preterm babies were randomly selected, we would expect how many to weigh 8 pounds, 13 ounces? We would expect how many to weigh 8 pounds, 13 ounces or more? How many? 100. 2 zeros, 2 places. If I'm looking at this at 1.7, what does that round up to? 2. So we would expect 2 out of 100 preterm babies to weigh 8 pounds, 13 ounces or more, right? Okay, yeah, preterm and still 8 pounds, 13 ounces. Holy cow. You wouldn't expect very many because that's full term size or even bigger, right? I have one son and he came out 7 pounds, 12 ounces. So, and he was full term. So that wasn't even a deal there. So this is a big baby for preterm. Nice, okay? Good. It's always nice to give that context so you can make sense of what we're actually doing with it.